In this movie, we're going to look at the design of the structure of our database system. We're going to sketch this out as an entity relationship diagram. First of all, let's take the customer entity and start to sketch in all the entities that we think should make up this particular database. We need customers and videos. Those are perhaps the most basic elements of our database. We also need to be able to split videos up by genre. Typically, a video shop will divide their stock on the shelves on the basis of genres of videos. So it's very important to be able to point the customer to the right section of the shop, and to make it easier when a video comes back in to know where to put that particular video. We also need some way of allowing customers to ask vague questions such as, what was the movie with John Travolta in it that was a kind of a trashy action movie? And for the system to be able to return some kind of intelligent response. We therefore have to be able to store some information about the videos, such as which actors appear in the particular videos that the customer is searching for. Another possible entity is the fine that the customer has to pay. That could be an important one. And we also have the employee entity and perhaps the boss entity. Now, all of these are simply ideas that I've sketched down, some of them translated directly into tables that are eventually used in the resultant database. Some of them, however, as we'll see in a moment, changed through the process of thinking about how the different entities relate to each other and the most logical way to structure the data. Videos need to be linked to customers. We'll start sketching in the relationships here, and this will often help us notice as we hit problems and have to restructure our entities. One customer can have many videos out, so we use one-to-many relationship there between videos and customers. Genre, each video has to be connected to a genre, so again we have a one-to-many relationship there as well. We also need to connect videos with actors, and presumably, since there's more than one actor within each video, we need a one-to-many relationship there as well. The problem here is the fact that we have many actors and many videos. So we could have, for example, an instance in which the same actor appears in different videos, but the same video also contains many actors. So we have a problem here with the structure. The way to solve this problem would be to include an extra conceptual entity called film actor. And this film actor entity will essentially act as a bridge between the actor entity and the video entity. This is to avoid problems that would arise if we tried to create a many-to-many relationship, something that's not possible because of our database architecture. We can fill in the lines here, and then it becomes obvious that the problem is solved by using the bridging table. Another issue arises with the fact that some customers may not know who acted in the film, but they may know who directed it. Or maybe they were so impressed by one particular film and the direction within it that they want to find out what other movies this particular director has made. So my first thought was to go through the same process of creating a director entity that would then presumably have to have a film director bridging table between director and video. I instead decided to generalize the actor entity into an artist entity, and then we'd have the bridging table would similarly be generalized. This would also allow the flexibility of actors who are also directors or also screenwriters and so on. It would allow us to get over the problem of the instances in which an actor directs and stars in the same movie. We'll look at exactly how these relationships work and at what point the nature of the work that the artist has done on the video will be included within the table. We'll look at that later on down the track. Another problem arises here in that the video and customer relationship is also problematized. If we have several copies of a single video, something that is very likely to happen, given that Video Shop does not necessarily want to have only one copy of any given video, especially new releases. Therefore, since the video is an entity of its own, we end up with the situation in which the information on one particular row on the video table is going to have to be duplicated for each copy of the video we have in stock. This has got to be a bad thing. This could lead to error, leads to redundancy, and if for any reason we have to update anything about one copy of the video, we'll have to go through manually and change the information on each copy of the video. A way around this would be to, first of all, to remove the direct relationship between the video and the customer, and then to break down the video entity itself. So now we have the video having several rents to the customer. So perhaps we could include a column within the video table that would say something like 5 copies. And then each time a customer rented a video, that number, a tally would be held somewhere, perhaps on another field in the video table, that could register the fact that, say, 3 of the 5 copies are out. This is a possible solution, and it solves the problem of the relationship between videos and customers to an extent. However, it is only a very loose and unsatisfactory solution. A better one, we would also include the fine within the rent if that rent happened to go overdue. A better relationship or structure for this video issue would be to separate the video from the titles. At the moment, we have a relatively ambiguous entity here, the video. Now, is this video representing a title or a physical video? If we use the rent entity, then we're able to consider the video to be a title. However, the problem then is that each of the videos will presumably have a single code. So if one of the videos goes missing, we have no way of telling which one it was or where we should go to look for it. A better way would be to remove the video entity altogether and the rents entity, and to replace those with a film entity and a copy entity. The film entity is essentially all the information about the film itself and all the relationships with genres and the artists that made that film would all be kept connected to the film entity. By creating a copy entity, we have one row on the table for one literal physical object. This is much better for tracking where a video has gone and so on. It also means that instead of a customer having some link to the film itself, there's one stage of removal there in which the customer now has a link to the particular copy that they hold. We can then reference the copy and find out what exactly that is a copy of by looking at the film that it's connected with. This means that when we want to make any change to the details about the film, we can make them in one place, and all of these will be reflected within any copies of the film that the video shop holds. It's also a good idea to store an unpaid information within the customer table. This is because the customer is perfectly at liberty to drop the videos in very late through the door of the video shop, and if we don't have a way of storing that information on the customer entity itself, then they'll never end up paying for those late fees. So we need to be able to store two different kinds of late fee, essentially. An unpaid late fee, such as the one I've just described, and a late fee where the customer still has the video out. And the reason why we don't want to store that information on the customer entity is that that's information that will change from day to day as the video gets later and later and the fees mount up. So we need to be able to calculate that based on the information that's stored in the copy entity, which is the copy was taken out at this particular time by this particular customer. Then when we go to query the data, we can extrapolate from that information and the day's date exactly how much the customer owes on those videos. The same is not true when the videos are returned. We don't want to have any residual information about late fees on the copy of the video that's been returned, because some other customer might take it out and thus remove that information. So we need to be able to store these two particular kinds of late fees separately. I'm going to generalize the fine entity to a charge entity. This allows us to put all the charges in one place. This will be a charge for new releases, charge for a standard release, charge for a fine that the customer has overdue, and so on. We also need a link with the copy to the employee so that when a copy has been taken out, we can keep tabs as the boss on exactly which employee rented out to which customer at what time. Presumably then we have the boss entity connected with the employee entity. However, again, this was something that I decided could be significantly simplified. The only difference between the boss and the employee is the different levels of privileges. They shouldn't really be separate entities within themselves. I therefore decided to take away the boss altogether and simply make the boss a kind of employee that had control over other employees. So that entity is therefore effectively related to, or rows within that entity are related to other rows. In our next movie, we're going to look at each of these entities in detail and start translating them into MySQL tables.